Good afternoon, my YouTube viewers. It is Crystal here. I'm just here because I want to do another code review, and this code review is going to be on the IRIS dataset. I'm sure anybody who is studying data science and machine learning will be familiar with the IRIS dataset. And basically, because the last two datasets I did were on a binary classification. So the first one I did was on the cheetahs and lions. So that was okay. And then the second one that I did was on horses and humans. And it was very easy to do the horses and humans one because humans are generally not as big as horses. So the dimensions of the humans and horses are different. So for that reason, I scored like a 99% accuracy. But I got this data set off of Kaggle, and it was the IRIS data set, and this is IRIS images. It was not a tabular data set. And since it was IRIS images, I thought, well, I want to do that. And the reason why I wanted to do that was because it was not a binary classification. It had 3 classes that it would predict upon. And so I thought, well, I want to do this. This is a little bit different than the binary classification, which means it will encompass different coding, and that was something that I wanted to do to build up my repertoire. So that's what I've done. So this is the IRIS dataset. I've got it off of the Kaggle website, and what I'm doing now is I will leave a copy of the code in the description box down below, so if you want to look at the code, you can. And the thing about this IRIS dataset is there's only code for 4 or 5 people in the dataset, and I made sure that I put my code in there, so my code is in there. So we'll go ahead and carry on with the code review. First thing that we will do is we will cover the problem statement. It says most data scientists are familiar with Fisher's IRIS dataset. The original IRIS dataset was used in R.A. Fisher's classic 1936 paper, The Use of Multiple Measurements in Taxonomic Problems, and can also be found in the UCI Machine Learning repository. The dataset presented here provides images for the species of the IRIS dataset that were chosen by Fisher. Can you classify IRIS images with computer vision? So that is your problem statement. So we created the program in Kaggle's Jupyter notebook, and so this Jupyter notebook is stored in the repository of the IRIS dataset, so you can find it in Kaggle because I've made it public. First thing we want to do is we want to import our libraries. So we're going to import NumPy as MP, so that's new numerical computations. We're going to import pandas as PD, so that is your data processing and creation of data frames. I would also like to say that you create NumPy arrays with NumPy. We're going to import OS, which is the operating system, which you're going to need that to be able to retrieve your files. We're going to import matplotlib.pyplot.splt, which gives you your graphics, and we're going to import Seaborn as SNS, which gives you some more graphics. We're also going to import sklearn, which provides machine learning functionality. We're going to import TensorFlow, which creates your neural networks. We're going to import PathLab, which is going to create a path for you. And we're going to import CV2, which is going to be your computer vision. We're going to import PIL, which also is related to computer vision. So we're going to be importing quite a few libraries to carry out this program. After we have imported the libraries, then we're going to get the files. We're going to use OS to get the files. And we got all of our files. So there's 3 classes of files, which is Setosa, Versicolor, and Virginica. So after we have gotten our files, what we're going to do is we're going to define our path. So data_dir equals Kaggle /Kaggle /input /Irish Computer Vision. And then dir data equals path live, path data dir. And then you look at data dir. So this is your path. Now what we're going to do is we're going to define our classes. We've got 3 classes of Setosa, Versicolor, and Virginica. And then so you can see that with Setosa there's 67 images, with Versicolor there's 269 images, and with Virginica there's 85 images. We're going to print random images of the irises. So we've got the number of columns is 3, the number of rows is 1, big size is 15:3, and the subtitle is category. So we set up a random integers for Setosa, Versicolor, and Virginica, and we call out these random integers to give us randomly selected flowers. And the reason why I did that is because I think it's really boring if you say, oh, we'll select number 1, or select 0. I think that's really boring. So every time you run up the program, you get a different random number, and you get a different random number, you'll get a different picture. So that's what I did. So here's your Setosa, your Versicolor, and your Virginica. So the Setosas really look a lot like Versicolors to me, but I'm not a flower specialist. I mean, Virginica, you can tell the difference between a Virginica right away, but it's a little bit more difficult to tell the difference between a Setosa and Versicolor. But that's what he did. That's what he's saying. It's a Versicolor, and I'm not a flower specialist, so I'll just have to take his word for it. But it does look a little bit like the Setosas and the Versicolor look very similar to me. Now what we're going to do is we're going to define our data frame. We're going to have a data frame of images, and the images are going to be Setosa, Versicolor, and Virginica. And we're going to have a data frame of labels, which is going to be 0, 1, 2. Now what we do is we're going to get the shape. And so I decided to get the shape of a Virginica, and the Virginica is 25, 25, 3, so it's 3 dimensions. And now we define our X and our Y variables. And when we define our X and our Y variables for every image, we're going to resize it to 224 by 224. And then so you can see here that we have 421 images. And now what we're going to do is we're going to convert our X and our Y to NumPy arrays. So X equals np.arrayX and Y equals np.arrayY. And we're going to split our X and our Y data set into training, validation, and test sets. So you can see that we've used sklearn to split it into training, validation, and a test set. And so now what we're doing is we're getting into TensorFlow. So we import all of our TensorFlow libraries right here. And you can see we're using 2.11. So TensorFlow goes through so many changes that it's important to know which version of TensorFlow you're working on. So that's an important thing to know. And now what we're going to do is we're going to convert our Y-train, Y-val, and Y-test to Y-trained cat, which is 2 categorical, Y-val cat, which is 2 categorical, and Y-test cat, which is 2 categorical. So that means that it will give you 3. What it does is it one-hot encodes Y-train, Y-val, and Y-test. That's basically what it does. It one-hot encodes it. And then now what we're going to do is we're going to define our model. So we set up our normalizer, and normalizer is rescaling the image to a value between 0 and 1, and you rescale that image by dividing it by 255. And then what we're going to do is we're going to use a pre-trained model called MobileNet, and I could use a different model. I could use like a VCC16, I believe, and see if I could get a better level of accuracy if I used a VCC16, a different pre-trained model. But I just happen to use MobileNet. Define our model. It's a sequential model because I've normalized the data. We have to set the input. So keras.input shape equals 224, 2243, meaning it's 3-dimensional. And then we put it through the normalizer, which I've already defined. We put it through MobileNet, which has already been defined. We put it through keras dropout. So dropout is supposed to improve your accuracy. And we're going to put it through dense. So it's going to be num label, and activation is going to be softmax. And you're going to look at your model summary. And so you can see your model summary here. Now we're going to optimize the model, set it up for atom, categorical, cross entropy, and accuracy. And after we have optimized the model, then what we're going to do is we're going to train the model, and we're going to set it up for epochs and early stopping and MC, which is model checkpoint. So we put it through all these epochs, and I think it does some early stopping. It stopped at 47. So now what we're going to do is we're going to predict on it. Prediction equals model.predict x test. Batch size equals 64. Verbose equals 1. Prediction equals np.argmax. Model predict x test. Axis equals -1. And that's for your multi-class. Prediction equals prediction.flatten, and then you have your prediction. So you've got some 0, 1s, and 2s. So we put it on accuracy score to check the accuracy, and it gives you a 63% accuracy. But I checked a tutorial on that, and the accuracy of the tutorial was a pretty close approximation of that as well. And the reason why is because it's more difficult to determine a picture of a flower than it is to determine a picture of a human and a horse. And then so we do model evaluate. So model.evaluate x test comma x y test cat. So that's categorical. And so again, you see you've got your 63% accuracy. So now we put it on a classification report, so you can see what the classification report looks like for the 3 categories. Put it on a confusion matrix. You can see what the confusion matrix is, and you can see that the Virginica didn't have a very good response. And now what we do is we check our actual values against the predicted values, and you can see that. And then we've got some plotting, some graphs plotting. I didn't make these graphs, somebody else did. I just used the code. But here's the plotting, so you can see the training accuracy versus the test accuracy, and then you can see the training loss versus the validation loss. And that's it. Now what I may do is I may try a different model and see if the accuracy improves with a different model. So that might be one thing that I can do so I can see if I can improve my score. So I would like to thank all of my subscribers for supporting my channel. If you like my video, please like, subscribe, and share. And thank you so much for watching this video. I look forward to making more code reviews for you in the future.